In this video, I'm going to be introducing the first derivative test. So let's start with a graph that looks something like this. If we take a look at the derivative between a and b, on this graph, the derivative between a and b is always going to be positive. Remember, one of our interpretations of the derivative is it is the slope of a tangent line. And if I draw a tangent line anywhere on this graph between A and B, it's going to have a positive slope. The slope of these tangent lines will always be positive because the tangent lines are increasing from left to right. So the first derivative, f prime of x, is going to be positive between A and B. Well, at B, if we were to draw a tangent line, it is going to be a horizontal line. And so we know that a horizontal line has a slope of 0. And since the derivative is the slope of the tangent line, then at this point B, the derivative is going to be 0. The derivative is equal to 0. And we know that we call that a critical point. We've learned in a previous video that any place where the first derivative is equal to 0 is called a critical point. Now let's look at between B and C. We would be on this part of the graph that is decreasing. If we draw a tangent line anywhere on this graph in this region, it's going to be decreasing from left to right, which means the slope of the tangent line is always going to be negative. So therefore, between B and C, the first derivative is going to be negative because the slope of the tangent line is negative because the graph is decreasing from left to right. Well, when we get down to point C, once again, we have a horizontal tangent line, a critical point, and so that's where the first derivative will be equal to 0. And then between C and D, we can see that we have positive slopes again to our tangent lines. And so therefore the first derivative is going to be greater than 0. So if the graph is increasing from left to right like this, we have positive slopes of our tangent lines and we have a positive derivative. When the graph is decreasing, the tangent lines have negative slopes, so it's less than 0. Well, we can use this information to help determine whether our critical points, where f prime of x is equal to 0, is a maximum, such as this one is a maximum point, what we call a relative maximum, or whether it is a relative minimum. In other words, a low point. This would be a relative minimum down here and a relative maximum. If to the left of our critical point we have a derivative that is positive, and then to the right of our critical point we have a derivative that is negative. In other words, we're going from positive or increasing slope to negative or decreasing slope, then this point must be a maximum. If to the left of our critical point we have a negative derivative, and then to the right of the critical point we have a positive derivative, negative and then positive, then we have a minimum point. Well, let's do an example. Start off with something straightforward to see how we would actually use this. So if we have a function, let's make it something simple, like f of x is equal to 8 plus 2x minus x squared. And we want to find the critical points and then determine if each critical point is a relative max or a relative min. So the first thing we have to do is find the derivative. which will be 2 minus 2x. Then we set the derivative equal to 0. This is our procedure for finding critical points. Or 2 equals 2x, or x equals 1. This means we have a critical point at x equals 1. Well, we know our relative extrema, our relative max and our relative mins, occur at critical points. But we don't know if this is a relative max or a relative min. So let's create a little number line. Let's put the critical point right in the center. And then let's identify a point to the left of it, such as 0, and a point to the right of it, such as 2. Now what I'm going to do is I'm going to take the first derivative and I'm going to evaluate both of those points. The first derivative at 0 is 2 minus 2 times 0, which is 2. Now what I'm really concerned with is the fact that this is positive. That means at x equals 0, the first derivative is positive. That means it's an increasing tangent line. So my tangent line, the derivative is positive, the tangent line would be increasing. Now at 2, f prime of 2, I have 2 minus 2 times 2, which is 2 minus 4, or negative 2. But once again, what I'm really concerned with is that this is negative. The derivative is negative here, which means the tangent line is decreasing. So if we have an increasing or tangent line to the left of my critical point and a decreasing tangent line to the right, because the slope is positive to the left and the slope is negative to the right, that means this point must be a maximum. And that is the first derivative test. Let's do one that is just a little bit more involved. Let's say we have the function f of x is equal to 1/3 x cubed plus 3/2 x squared minus 10x plus 12. And we want to find the critical points. So we want to find the critical points and then classify each critical point as a relative maximum or a relative minimum using the first derivative test. So to find the critical points, we find our derivative. So 3 times 1/3 is 1x squared. 3/2 times 2 would be 3x minus 10. Setting that equal to 0 and factoring it, we're going to have x plus 5 times x minus 2 equals 0. So x equals negative 5 and x equals 2. Those are my two critical points. Two critical points, negative 5 and 2. So let's draw a line. Whoop, that's not the line I wanted. Let's just draw a number line. And let's put both of these points, so negative 5, let's put them both on the number line. Now let's take a point that is to the left of negative 5, such as negative 6. Something that's in between these two, that would be 0, as long as it's not undefined at that point. And then something to the right of 2, 3. We don't want the point to be too far away. And let's test each one of these points in the first derivative. So first of all, let's do negative 6. So f prime of negative 6 would be negative 6 squared plus 3 times negative 6 minus 10. Well, that's 36 minus 18, that's going to be positive. That's really all I'm concerned about. This is positive. So we're positive at this point, which means we're increasing. At 0, the first derivative at 0 is 0 squared plus 3 times 0 minus 10. That's going to be negative at that point. The answer is negative. So we have a negative derivative, negative tangent line slope, so it's decreasing. And then from 2 to 3, at 3, we have 3 squared plus 3 times 3 minus 10. So 9, 18 minus 10. Again, that's going to be positive. And so we have increasing tangent line. So we can see from this that right here, we're going to have a maximum. It's increasing and then decreasing. Here at 2, we're going to have a minimum point because it's decreasing and then increasing. So we can say that x equals negative 5 is a relative maximum, and at x equals 2, we have a relative minimum. And that is how you use the first derivative test to determine whether your critical points are relative maximums or relative minimums.